Ever wonder how scientists can see what's hidden deep inside a solid object? Without smashing it to pieces. Well, today we're diving into the amazing tech that lets them do just that. We're going to look at how they peer into the invisible. And there's this one revolutionary new technique well, it's changing everything. I'm talking about everything from the batteries in your phone to how we understand our own planet. All right, so just picture this for a second. Let's say you're a scientist and you've got this tiny piece of rock, maybe from a shale gas field, or maybe it's a tiny part from a brand new type of battery. And your job is to see what the inside looks like. Not just a flat picture, but in full 3D, and at a scale so small, you can't even imagine it. So, how in the world do you do that? Well, the answer is a really cool technology called X-ray computed tomography. You've probably heard of CT scans, right, for medicine? This is basically the same idea, but for material science. It uses X-rays to build this incredibly detailed 3D digital model of whatever's inside an object. It's like having magic glasses that let you see into the invisible. But, and this is a big but, to even use this powerful tool, scientists have to tackle this huge challenge first. And you know what's crazy? The biggest challenge isn't the super expensive multi-million-dollar scanner. Nope, it's something way more basic. It's all about preparing the perfect sample. This is the first, and honestly, probably the most important step in the whole process of seeing the invisible. So here's the thing that really gets me. The quality of that final 3D image, it has almost nothing to do with how fancy the scanner is. As one researcher, Francesco Iacoviello, said, sample preparation is the linchpin. I love that word. It means everything depends on it. If you get the sample wrong, you get a blurry, totally useless image. But if you get it just right, well, that's when you make a groundbreaking discovery. Right, so if getting that sample perfect is the key, you can probably guess what's coming next. For decades, scientists have been wrestling with what you could call the preparation problem. And it's not a small thing. It's a massive struggle that has literally held back who knows how many big discoveries. Okay, to get those super high-res images, the samples have to be unbelievably tiny. We're talking about a target size of around 64 microns. Now, a micron is a millionth of a meter, which is hard to wrap your head around, so let's try this. The average human hair? That's about 70 microns thick. So yeah, scientists need to create a perfectly shaped little pillar of rock or metal that is thinner than a single strand of hair. Just let that sink in. And it gets even harder. It's not just about making it tiny. The sample has to be the perfect shape, otherwise it'll mess up the X-ray image. It has to be mounted so it is absolutely perfectly still. We're talking it can't move even a nanometer, which is a thousandth of a micron, during the scan. And maybe the most important part, you have to do all this without damaging the sample. No scratches, no cracks, because any tiny flaw you create could look like it's part of the material's actual structure. So you're probably asking, how on earth did they do this? For years and years, the only way to tackle this almost impossible task was to do it by hand. And really, it was less like a precise science and more like a form of art. A really, really frustrating form of art. Seriously, imagine being a watchmaker or a jeweler, but on an even smaller scale. That's what it was like. You'd have a researcher hunched over a microscope for hours, using these teeny tiny saws and knives to cut the material down. Then they'd use these super fine abrasive papers to grind and polish it into a perfect little cylinder. And after all that, they somehow had to mount this microscopic speck onto a holder with glue or tape. It's just so delicate and so incredibly painstaking. But here's the catch. This whole manual process, it's painfully slow. It takes a ton of skill, and even the best researchers couldn't get it right every single time. So you couldn't easily reproduce your results. And even worse, the risk of just slipping and destroying the sample, or even losing it completely, was huge. And when you get down to that 64 micron scale, the researchers themselves called it nearly impossible. They were hitting a wall. A new solution wasn't just a nice to have, it was desperately needed. And that solution, it arrived in the form of a focused beam of light. This is where the story gets really good. Enter our hero, a laser-sharp solution that was about to bring incredible precision and speed to this tiny, microscopic world. So instead of all that grinding and polishing by hand, scientists can now just point a super-powered, ultra-precise laser at the material. The laser beam literally vaporizes, the technical term is ablates, the material, layer by tiny layer. It just carves out a perfect sample with micron-level accuracy. It's incredible. And because the laser uses these ultra-short pulses, it does all this without creating a lot of heat, which means it doesn't damage the sample around it. And this just shows you how big a deal this is. I mean, look at the difference here. The old way, not very precise, totally dependent on who's doing it. The laser, micron perfect every time. The old way was slow and laborious. The laser is fast, and you can even automate it. The risk of damage? It basically disappears. And all of a sudden, you can create these complex 3D shapes that were just a fantasy before. So let's be clear. This isn't just a tiny step up. It's a total game changer. Okay, so what does a game changer like this really mean in the real world? Well, it means unlocking whole new areas of modern science. This one single jump in technology is having a huge impact across so many different fields. Let's start with battery research. We all want better, longer-lasting batteries, right? For our phones, for electric cars, for everything. Well, to build them, scientists have to see exactly how the insides, the electrodes, break down over time. And this laser technique lets them create the perfect little samples to watch that happen in real time. It's massively speeding up the whole process of developing the next generation of batteries. Or how about the energy sector? Researchers can now take a piece of shale rock, carve out one of those perfect tiny pillars, and literally map out the maze of pores inside. This gives them a crystal clear picture of how gas is stored in the rock and how it flows, which of course leads to much smarter and more efficient ways to get it out. And it goes even deeper than that, literally. In geosciences, scientists are using this to look at the microstructures of minerals with a clarity that was just impossible before. This is giving us brand new insights into the history of our planet and the huge geological forces that are constantly shaping the world under our feet. So, in the end, it really comes down to this. This laser technique has become what they call an enabling technology, and that's the perfect way to put it. It didn't just make an old method a little bit better, it blew the doors wide open to entirely new possibilities for what scientists can see, and, by extension, what they can discover with this incredible imaging technology. Think about it. For the very first time, we have a reliable, repeatable way to prepare and see these hidden worlds. The single biggest roadblock that was holding back discovery for decades, it's just gone. So the only question we have left to ask is, now that we can see everything with this near-perfect clarity, what are we going to uncover next?